I know how excited you guys were about statistics, so I decided we had to get back to work on it. I'm still at home. I am recovering from my injury. Most of you probably know I hit a tree with a snowmobile and fractured my pelvis in a couple different places. Um, Anyways, we're going to start off just about where we left off last time. Last time we talked about the placebo effect. Placebo effect occurs when a subject reacts favorably to a placebo when in fact they're being given a fake treatment. We talked all about this. We had that video that we watched at Princeton where they were giving them non-alcoholic beer and people were acting drunk. That was a placebo effect. They were being given non-alcoholic beer, but it tasted like regular beer. So they decided, or in their brains, they thought that they were getting drunk. Blinding is used to control or minimize the placebo effect. Remember, blinding is whenever they are, the researchers don't want you to know whether you are getting the drug or whether you are actually getting a placebo. These notes are kind of long, I will tell you that. Um, so blinding is a technique where subjects don't know whether they're receiving the placebo or treatment. In a double-blind experiment, neither the experimenter nor the subject knows if the subjects are receiving the treatment or a placebo. One of the reasons they want to do that is if you put all your effort into developing a drug that is supposed to, say, cure depression or make you not as depressed, then you would ask people questions along the lines that you're trying to get the answer that you're looking for. So you've been working on this drug for 20 years. Instead of going up to someone and saying, is this making you feel any better? What was happening was that the people who were doing the experiments were going up to the people and say, you're feeling better, aren't you? Just so that the people would respond positively to the drug. So that's why they use double-blind experiments, just so people don't know, nobody knows who is actually getting the drugs until the end of the experiment. Randomization. Randomization is the process of randomly assigning subjects to different treatment groups. One of the reasons that you want to do this is you do not want to have people who think alike or are based off of gender. You don't want them all to be in the same group. So you want to randomize it so that they go into different groups. One type is a completely randomized design. Subjects are assigned to different groups by random selection entirely. There's the randomized block design. That's where the experimenter divides the subjects with similar characteristics into blocks. Then within each block assigns subjects to treatment groups. So you will have, this is where you could have females in one group because they have similar characteristics, males in another group, so that would be your two blocks. Then within your blocks, some of them would get treatments, some of them would be the control groups. So say we have 100 females, 50 would get the actual treatment, 50 would get a placebo or be part of the control group. And then you would have 100 males, and 50 of the males would get the placebo, 50 of the males would get the actual treatment. The other one is a matched pair design. Subjects are paired according to similarity. So one subject in the pair would receive one treatment, while the other subject would receive another treatment. So you would pick pairs based off of demographics, like 30-year-old white female. We would get two 30-year-old white females, and we would pair them together. One of them would get the placebo, the other one would get the treatment. Then we would take another pair. It could again be 30-year-old white females, or it could be 20-year-old white females. Then we could move on to African Americans. So it could be two African American males, where one of them gets the treatment, one of them gets the control. The problem with this one is you would have to match the pairs each time and then move forward with the experiment based off of that. It's kind of time consuming to put together. Analyzing the experimental design. So here we want to figure out if the design is good or not. A company wants to test the effectiveness of a new gum developed to help people quit smoking, identify a potential problem with the given experimental design, and suggest a way to improve it. The first one, the company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and the other 5 subjects are given a placebo. After 2 months, the subjects are evaluated, and it's found that the 5 subjects using the new gum have quit smoking. Okay, so if we're looking at this design, there's only one problem with it. The problem is that we don't have enough test subjects. If we're saying right now 5 subjects quit smoking, those 5 subjects could have thought that they were could be predisposed to quitting smoking. They might have actually wanted to quit smoking and moved on. It also doesn't tell us that we've looked back to see how many people who were given the placebo quit smoking. So that's the flaw in this design. We need to be checking how many people quit smoking who were given the experimental treatment and how many people quit smoking who were given the placebo or were in the control group. Also need to have a much larger sample size. And that's the most important part here. We need to have a much larger sample size. Okay, let's look at the second one. The company identifies 1,000 adults who are heavy smokers. So now we have a larger sample size. Subjects are divided into 2 blocks according to gender. Females are given the new gum and males are given the placebo. After 2 months, a significant amount of females have quit smoking. Okay, so this kind of seems like we're doing a sample based off of like a matched pair design or something like that. However, all the females are given the new gum. All the males are given the placebo. So, after 2 months, a significant amount of the females have quit smoking. This would be a great plan if we were trying to figure out how it affects female smokers. However, we do not know how this drug would affect male smokers at this time, because we did not give the drug to male smokers. It could be something to do with hormones that it's stopping. It's helping the females to stop smoking. It could have something to do with their genetic makeup. Because of that, we cannot use this as a proper design experiment. So, the best way would have been to split the blocks and give half of each the treatment. That way, if we had our blocks divided the way that they were, according to gender, half the females would be given the treatment. We would see how many of those quit. Half the males would also be given the treatment. Now we can effectively decide how it's affecting all people as opposed to just females. Number 3, company identifies 240 adults who are heavy smokers. So it's a smaller sample size again, but 240 is perfectly fine. You want to try to stay above 100. Subjects are randomly assigned to be in a treatment group or in a control group. Each subject is also given a DVD featuring the dangers of smoking. After 4 months, most of the subjects in the treatment group have quit smoking. So there's a problem with this one. Once again, we did not discuss the effects of those in the control group. That's one problem. The other problem is that each subject was also given a DVD. Whenever you are doing an experiment, you only want to have one variable. You do not want to give them gum and the ability to watch this DVD in order to kind of perturb them from smoking. So this would curb their addiction or their need to smoke, but we don't know which one is making that happen. Is it the gum or is it the DVD that is stopping them from smoking? Now we're moving on to sampling techniques. So there's a lot of different sampling techniques that can be used. First one is a census. A census is a count or a measure of an entire population. So we do a census in the United States once every 10 years. There's a census that gets sent out. You are required by law to fill it out and send it back. Now, problem with the census is it provides all the information, but it's very costly and difficult to perform. In general, the statistics that we get from the census, like the 2010 census, those didn't come out until like 2013, 2014 because of the large amount of data that it is. Plus, you're literally sending it out to every house in America. A sampling is a count or measure of part of a population. So this is much more commonly used. Research needs unbiased data in order to represent the population. So we would want to be across different genders, across different age groups, and across different races and nationalities. Appropriate techniques must be used in order to ensure that inferences about the population are valid. So you're going to take a sample, and then you're going to use that sample to make an inference about an entire population. But the appropriate techniques are the most important part. If you're not using appropriate techniques to get a sample, then you're going to end up with a sampling error. The sampling error is the difference between the results of a sample and those of the population. Sampling errors are always possible. If we would go back to the election, one of the major issues was that there was a sampling error whenever they were the Gallup polls, and there's another poll company. But when they were doing the polls, before the election, they were sampling much more people in urban areas, and like along the East Coast, the West Coast, they were leaving those middle states out where it was a lot of farmers and things. Because they weren't sampling those areas largely enough, all the polls heading into the election said that Hillary was going to win, and it was going to be a landslide. But they weren't taking those farmers and all those people into consideration nearly enough. A lot of them turned out to vote, and that's why we ended up in the current landscape we're in. Again, it's almost impossible to know every possible sampling error right off the bat. You just try to come as close as you can to getting a good sample. These are the different techniques that you can use to come up with different samples. The first one is called a random sample. It's one in which every member of the population has an equal chance of being chosen. So they are just literally pulling numbers out of a hat, or names out of a hat. The second one is a simple random sample, or SRS. I only do that because it's really difficult to write out a simple random sample every time. This is a sample in which every possible sample of the same size has the same chance of being collected. Normally we start by using a simple random sample. Random samples can be drawn from a random number table. You'll see a random number table in your notes and on the next page. The reason for a random number table is that we can kind of approximate things without actually having to go out and take a sample. So here's a table of random numbers. Underneath this, in your notes and on the next page of the slides, is an example problem where we can use a random number table. Using a simple random sample, there are 731 students currently enrolled in a statistics course. You wish to form a sample of 8 students to answer some survey questions. Select the students you would choose for the simple random sample. So now we're going to go through the process of using a random number table in order to select the students. So there's a couple different ways you can do this, but it always starts the same. You assign a number, number from 1 to 731 in each, or to each person. Now, from here, you can automatically say, oh, well, I can pick random numbers, 255, 645. Those aren't completely random numbers. So the easiest way to do it is to go back to your random number table. And you say, okay, I'm going to select the first 3 numbers. So using this number table, I could do the first 3 numbers or the middle 3 numbers or the last 3 numbers each time. The only thing that makes a difference is that I have to make sure I use the same 3 each time. And so then I can just go say, I'm going to go across the row. So I'm going to say first 3 numbers across the row. So it's going to be student number 365, 367. Now look, here we have 891. That's above 731, so we can't count that. And it's number 55, 297, 837. Again, it's above 731. 215, 816 is too high. 279. So 1, 2, 3, 4, 5, 6. And 624. And 628. Those are completely random numbers. I did not have any bias when I selected them. I just went straight across the row of the table. I always made sure I used the first 3 numbers so that my bias could not come into it in any way or form. Again, I could have done this a different way. I could have done last 3 numbers. That would have been person number 132, 380, 635, 428, 48. That one's bad. 92, 615, and 46. As long as you're consistent with the way that you do it for all 8 people, then it's perfectly fine, whether you do front 3 numbers, back 3 numbers, or middle 3 numbers. Next is a stratified sample. It's used when it's important to have members from multiple segments of the population. First, the population is split into segments called strata. Then a predetermined number of subjects is chosen from each of the strata. Okay, an example of this is, do you travel on European cruises? There's either one or 2 answers. You'd either be a yes or a no. So I go out and I ask a bunch of people this question. I would either get one answer or another, yes or no. Those are our strata. So yes would be one and no would be the other. Then we could say ahead of time, we want 20 people from each of the strata. So the first 20 people who say yes are going to be in our study, and the first 20 people who say no. And that's it. As long as they're from the different segments of the population, the yes and the no. Cluster sampling. This can be used when the population naturally falls into subgroups with similar characteristics. First, determine the clusters, then select all the members of one or more of the clusters. This is obviously Beaver County. So the way that we would do this is we would pick people from certain clusters. So we would say, okay, we are going to look at every person from New Swickley. Hold on a second. Sorry about that. We're going to look at every person from New Swickley, every person from Center, Hanover, and Aliquippa. These are clusters that we are looking at. We're looking at the cluster of New Swickley, the cluster of Center, the cluster of Aliquippa, and the cluster of Hanover. This is kind of a problem because it has to be all members of the cluster. So I have to talk to every person in New Swickley. I have to talk to every person in Center, every person in Aliquippa, and every person in Hanover. Now, if we're just talking about adults, then I would have to talk to every person over the age of 18 from New Swickley. But we have to fit everybody in from each of those clusters. Systematic sampling. Systematic sampling first involves assigning a number to each member of the population and ordering them in some way. So we're going to assign a number to each person in the population, so to each person in Aliquippa. And we could start with addresses. I mean, start right on Broadhead coming into Aliquippa and start with addresses. Sample members are selected by choosing the first member randomly, then selecting subsequent members at regular intervals after the starting number. For example, every 7th person. So we decide that we're going to start each house coming down Broadhead. So we select the first house, and then we say every 4th house we're going to need in this study. Now this method is fairly simple to use, but it should be avoided if there are regularly occurring patterns in the data. One example of that would be if I am looking at everybody coming down Broadhead, for example. If everybody on the same street has the same philosophy, is of the same gender or the same race, then it could end up with a regularly occurring pattern in the data that could screw up our sample. A convenience sample. This consists only of available members of the population, but it often leads to biased studies. An example of this would be something that's current in our current climate right now. If I was to ask simply, do you think that there should be stricter gun control laws? And I just went out and went to, say, Parkland, Florida, where there was just this shooting. If I went there and I asked the population that, do you think there should be stricter gun control laws? The majority of the people are probably going to say yes. So it's convenient for me to go there, but it leads to a biased study. It's convenient for me to go there because a majority of people are going to want to answer this question. But we know what their response is going to be ahead of time. A volunteer sample is a kind of convenience study in which only volunteers participate. This is also can lead to biased studies, and the reason is that if it's something that you care about, you're going to want to answer it. But if it's something that you're not necessarily passionate about, then you're not going to answer it nearly as often. Okay, we're going to go through these sampling techniques. You're doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling technique used. Okay, you divide the student population with respect to majors and randomly selecting questions from students in each major. So the first thing we did was we divided it into majors. Because we divided it into majors, we made those strata, which makes this a stratified sample. From there, we questioned people randomly from each strata, so that's how we know that it's stratified. Number 2, you assign each student a number and generate random numbers. Then you then question each student whose number is randomly selected. So we gave everybody a number, generated random numbers, then questioned each student. This is a simple random sampling. That's because we gave everyone a number and then randomly generated the numbers that we were going to question. Lastly, you select students who are in your biology class. Okay, this comes back to one of the ones that I think is pretty self-explanatory. This would be a convenience sample. I don't have to go out of my way to do anything. It's just the people who are in my class. So I can turn around and say, raise your hand if blah, blah, blah. That's one of the things with the convenience sample I don't think I really touched on instead of talking about the bias that can occur. Like one of the reasons it makes it so convenient is that you don't have to go out of your way to assign a random number or to break it up into groups. All you're doing is turning around while you're in your class and saying, what do you guys think of this? Now, one of those biased results things is if your entire class is failing and you turn around and say, you know, what do you think of our biology teacher? Then a lot of them are going to have the same reaction as you do. Okay, determine which kind of sampling was used in each of the following scenarios. To determine the quality of on-campus housing, 20 residents from each dorm were chosen to complete a survey. So because it's from each dorm, and there's 20 residents from each one, that makes it a stratified sampling. We broke them into groups and then randomly selected 20 people from each one. Part B. To evaluate employee compensation, choose a random sample of 10 zip codes in the state, then survey all businesses within each chosen zip code about their benefits package. Okay, this zip codes thing is a good way to tell what kind of sampling it is. This is going to be a cluster sample. Just like we chose people from the towns in Beaver County, we're essentially doing the same thing. We're picking everybody from that area. So it's all businesses within the 10 zip codes. So we're choosing everybody from within those clusters of areas. Next will be those who participate to a survey linked from CNN.com. That would be a volunteer sample. They're willing to go online, go to CNN.com, and pick or fill out the survey. So they're picking their answers, filling out a survey, but we can't force them to do that. They're doing it all on their own. To determine the quality of education at the University of Utah, a unit number is chosen at random. Then every 1,000th student is evaluated until 30 students are selected. So this would be like university ID number is chosen at random, and then every 1,000 student after that. So this would be a different type of sampling than any of the ones that we've done. This would be a systematic sampling. Choose one random person, then we put a system in place with every 1,000th student. Interested in only one neighborhood, you walk door to door and ask residents questions. Since your time is limited, you do not have a chance to revisit the houses where no one answered the door. Once again, this is a convenience sampling. I don't go back. I don't check to see if that person is any different or has any different thoughts. I just go with what I have right away. Lastly, interested in only one neighborhood, you walk door to door and ask residents questions. Everyone was home and willing to participate, so you have survey results from every household in the neighborhood. Now there's an important word in there, being every. That tells us that this is a census. It's a census because it covers every single household in your neighborhood. All right, guys, I know that was a lot, but that is it for the day. I will have another, that's it for our entire chapter. So 1-3 is done. I'm going to have you do the work on it now. And then tomorrow I will have the answers to all the odd questions. Day after I'll have all the answers to the even questions. We'll go over those.